Assalamualaikum everyone. Hello, how are you today? Welcome back our my YouTube channel. Today we will talk about math. Of course I am. But today we will talk about application of the second derivative part 2, or we call it the second derivative test. But before that, if you like my YouTube channel, please like, subscribe and comment. Okay everyone, without further ado, so please enjoy this video. Okay, now the second derivative test, let f be twice differentiable, is that meaning they have to differentiate on an interval e, and c be a critical point of f in e such that the first derivative ch equals 0. This one is critical point, you already learned about this one. And the second derivative, if more than 0, then f has a local minimum at x equals c. And then the second is the second derivative, if less than 0, then f has a local maximum at x equals c. So now we are see in the left side, the graph is open. So that's the meaning they have the local minimum at C, and in the right side they have a local maximum at C. So this is the highest one, this is the lowest one. But from here we already know in this side is the first derivative. The first derivative is what? Yeah, this is increase, so more than 0. So this is, yeah, this is increasing too. Increase. How about in the left side? In the left side from here, this one is decrease, and then this one is, this one is decrease. Now from here we are see this one is the second derivative of C is more than 0 or concave up, and then in the right side this one is concave down, and then in the front here they are concave up, or the second derivative more than 0, and then the last is concave down. Correct, this one is concave down. Okay, now we will talk about the example. So let's get it. Example 41. Apply the second derivative test to find the local extrema fx equal x power 3 minus 3x squared minus 9x plus 6. Because they told us about the second test, so we should using the second test. So the first derivative is 3x squared minus 6x minus 9, and then the second derivative test is 6x minus 6. Okay, because they ask about local extrema, we already know local extrema is equal 0. So this one, 3x squared minus 2x minus 3 equal 0. So we factorize this one, x minus 3, x plus 1 equal 0. So x equal 3 or x equal minus 1. So this one is critical point on f. Because they wanted us to using the second test, so you need to compute this one to the second derivative. So second derivative of 3 is 6 times 3 minus 6 is equal 12. And then minus 1, it's equal 6 minus 1 minus 6. So this one, it will be minus 12. Okay everyone, so you should substitute this one to this second derivative. Since the second derivative minus 1 is less than 0, so this one, so we can substitute to be minus 1. So when you substitute this one to from here, minus 1 minus 3 plus 9 plus 6 equal 11. So this one we get the 1. And then how about f3? F3 is more than 0. So when we substitute this one, when we substitute this one is equal minus 21. So from here we get this to score. We got to score is 11 and minus 21. So local maximum, this is local max. How about local minimum? This one is local minimum. So this one is have some result in example 24 if you want to compare this one. Okay, now we will another example. Second derivative can be used only. The second derivative can be used only if the second derivative exists, everyone. Okay, this one, if fall, the test fails when the second derivative of C is 0. Okay, find the local extrema of fx equal 3x power 5 minus 5x power 3 plus 3. So we can solve this one using the second derivative if the second derivative is exists. So let's prove this if this function exists in the second derivative. So we need to find the first derivative. First derivative is 15x power 4 minus 15x power 2. Okay, now we need to find the second derivative of this function. The second derivative is 60x power 3 minus 30x. Okay, because they wanted us to answer in local extrema. So local extrema is the first derivative is equal 0. So because this one is the same, we can factorize together. 15x power 2, x power 2 minus 1 is equal 0. So this one get x equal 1 or x equal minus 1, and then this from here x equal 0. So the 3 of this one is, yes, correct, this one is critical point of this function. So from here we can substitute to this function to get to using the second derivative. So the second derivative of 0 is 0 when we substitute, and then from 1, 60, 30, from minus 1 is minus 60 plus 30, it's equal minus 30. So okay, from here we see this one is 30 is local max. In here minus 30 is local minimum. But maybe you're curious why the second derivative of x, which is x equals 0, is result is 0. So this one is not give information about critical point of 0. So this one doesn't have any information about critical point. So let us apply the first derivative. Let us apply the first derivative. Now we will using the sign chart. From here we will using the sign chart. So this one is at. So we will put minus 1 here, minus 1, 0, and 1. Okay, in here minus infinite, and then in the right side is plus infinite. And then take another score from here, and then substitute from the first derivative. Okay, when you substitute this one from the first derivative, let's say this one minus 2, minus plus, let's say, and then when you minus 2 and then put this one, is the result is positive, negative, positive. Okay, everyone, from here we see this one is concave up, this one concave down, and this one is concave down, this one is concave, this one is concave up. Okay, everyone, from here we are see the first derivative doesn't change sign from from 0, from x equals 0. From here, the up doesn't change. X doesn't change at x equals 0. Okay, everyone. From here we are C because this the same down arrow doesn't have to change. So F doesn't have local max or minimum. Okay, everyone. Please do your check yourself. Check yourself 10 pages 115, number 1 until 3. Thank you everyone for watching my video. I hope you enjoy my video. If you have any comment, please comment in the YouTube below. And then if you have suggestion about another, like another subject, okay, we will try it maybe, yeah. So but now we will focus on the math. So thank you for today. Assalamualaikum warahmatullahi wabarakatuh.